Hello and welcome to section 4. In this section, we are going to talk about a special type of neural network, which is convolutional neural networks. Hello and welcome to this video on Introduction to Convolutional Neural Networks. In this video, I'm going to take you very quickly through what are convolutional neural networks. And subsequently, I will show you some demos on how we implement CNN in TensorFlow. I will show you initially how it is done in TensorFlow 1.0 and then what are the changes in TensorFlow 2.0. So let's get started. We have seen in an earlier section that neural networks is like the brain behind artificial intelligence. This is modeled around the human brain. And we have seen a neural network looks or represented somewhat like this. There is an input layer, there is a hidden layer, and then there is an output layer. And we also have seen what are known as deep neural networks. While this is the most common form of a neural network, this is not very helpful in some of the applications like image recognition. That is where the concept of convolutional neural networks comes in. In convolutional neural network, all the outputs or all the nodes are not interconnected. Only a portion of the outputs are connected to maybe some of the inputs of the next layer. So that's the difference between a convolutional neural network and a normal, fully connected or a dense neural network. And convolutional neural networks are used for image recognition. So this is a common architecture, if you will. There are rather a few convolutional layers. There are a few pooling layers. Typically, a pooling layer follows a convolution layer. And then towards the end, there is one or a couple of fully connected layers, followed by what is known as a classification layer, which typically has softmax. So this is by and large a high-level architecture how a CNN neural network or convolutional neural network would look. However, there are some variations of this possible. And there are already quite a few trained CNN models that are readily available for us to use and develop our applications. Let's take a quick look at those. The first one was LeNet, and this was developed by Jan LeCun and team. That's where the name LeNet comes from. These were the guys who were working on MNIST problem, if you remember. And they were the first ones to come up with the convolutional neural network architecture. Then we have AlexNet, and subsequently quite a few more trained open source neural networks like ZFNet, GoogleNet, VGGNet, and more recently ResNet. So these are open sourced. Anybody can use these and develop our applications. Training a convolutional neural network requires a lot of computational power. So typically, if somebody wants to develop an image recognition application, they would reuse some of these trained networks and develop their applications. However, if you have to train your models for something very specific, then you need to create your own convolutional neural network and train it. So we'll see how we can do that in some of the demos. Now, how does this work? At a very high level, this is how a convolutional neural network works. There will be multiple layers, as I have mentioned earlier. So when it takes an image, it kind of identifies the features in that image. It starts with the very low level features. This is what the initial layers will perform. When we say low level features, these are like edges, like curves, vertical lines, horizontal lines, slant lines, and so on, right? All those are low level features. And the subsequent layers will start identifying higher level features. So for example, if we are working with the image of a dog, it will start the higher level features could be the eyes, the ears, and relative position of these features, the mouth, the paws, and so on and so forth. And then finally, pretty much the last few layers will identify the complete object. So this is how a convolutional neural network works. This is another representation of the same. As you can see, there are multiple layers here. There are convolution layer followed by a pooling layer. And then towards the end, there are two fully connected layers. And then there is a classification layer, which has capability to identify 100 classes. And how do these layers work? As you can see here, the initial convolution layers are identifying these edges like slanting line, horizontal line, and maybe some curves and so on. Then the following layers identifies the texture, then the subsequent layers identifies some object parts, and then finally the actual object itself. This is the architecture of LeNet CNN model. So this has 2 convolution layers followed by 2 pooling layers, and then it ends with 1 fully connected layer and a classification layer or a softmax layer as it is known as. So this was used in the MNIST example where they try to build a neural network to classify handwritten images. So this is broadly this convolution and pooling alternating layers. All this together is known as the feature extraction section. And then you have the classification section, which consists of these fully connected layers. It could be 1 or 2. And then it ends with 1 layer, which has the softmax layer. So this is one of the variations, and there are multiple variations possible for this. And we will see in our demo how to implement this particular model. And we will be using Keras API to implement that in our code in the demos.